Algebra 2, 7-1, graphing exponential functions. So we're going to get into a little bit of an example. What does an exponential function look like? It might look like this: y equals 5 to the x power. Now we're going to write this again: y equals b to the x power. We're going to talk about some possibilities for this b here. So the absolute value of b is greater than 1. If the absolute value of b is greater than 1, then you've got exponential growth. If 0 is less than the absolute value of b is less than 1, so this means it's a fraction between 0 and 1, or between 0 and -1. Then you've got exponential decay. All right, and we'll look at both of these, growth and decay. Let's start with growth. Now the parent graph looks like this: f of x equals b to the x power, where b is greater than 1. So here's what our exponential graph looks like. So if I'm going to plug in some values for x and show what I get for f of x. If I plug in 0 for x, so 0, any number to the 0 power is 1. So b to the 0 power is 1. So I got a point at 0, 1. And if I plug in -1, then I get, now remember, if I have a negative exponent, that doesn't mean anything that's negative here. It means that this, what that does is it says, I want this number to go underneath the fraction bar. So this goes 1 over b. And then if I plug in 1, I get b. b to the 1 power of 1 is b. Okay, so I don't really know what b is, but we'll just make it up. You'll still see what this looks like. So b could be 2 for all we know. So let's say it's 2. So I go to +1 and I go up 2. That's what b is, we'll say. And then if I go to -1, I go to 1 over 2. So that'd be like right here. And what happens here is I have this graph that looks like this. It keeps going up and up and up and up forever. And when you go this way, when you are looking to the left, when you're getting more and more negative x values, this curve will never hit the x-axis. The graph never reaches the x-axis. Or y equals 0, right? That's the x-axis. So that means y equals 0 is an asymptote. So an asymptote means the graph is coming closer and closer to it, but never reaches it. So that's an asymptote graph. Never reaches it, gets closer and closer and closer, but never ever gets there. Okay, so let's talk about the domain and the range of one of these things. And let's do an example. So we're going to graph this, and we're going to talk about the domain and range of it. Y equals 3 to the x power. So let's draw a coordinate plane. Let's do a t-table to help us with this. So when let's plug in a bunch of numbers here. Let's plug in -2, -1, 0, 1, and 2. Let's try all those. So let's plug in 0 first. That's the easiest one. 3 to the 0 power is 1. 3 to the 1 power, or the power of 1, is 3. And 3 to the power of 2 is 3 times 3, which is 9. All right, those are easy, right? Let's do these ones now. 3 to the -1, 3 to the -1 is 1 over 3. So I just take that negative, that tells me put this on the other side of the fraction bar to make this 3 happy. So 1/3. Now here I've got -2, so 3 to the -2, that means I need to take this and put it underneath 3 to the +2. Once I get it underneath to the other side, then it's happy, it's positive. So 3 to the +2 is 1 over 9. All right, so now let's go ahead and graph these. So let's make some pretty big marks here. Okay, -2, 1, 2, and 1/9, so that's going to be pretty close to the x-axis. -1, 1/3, still pretty close. 0, 1, there we go. 1, 3, and then 2, 9 is way up here somewhere. And so I'm going to draw my graph. It looks like this. So this shouldn't come up here. I just did that on accident. It should just be always getting closer and closer to the axis. Now let's talk about the domain and the range. Domain and range. So I'm looking at my x values. So if I go all the way to the left as far as I can, I will still have x values on this graph. If I go to the right, this is going to go up and up forever, but it's also going to the right forever. So my domain is -infinity to +infinity. My range, now I'm looking at the y values contained on this graph, or included on this graph, and it goes up to +infinity, but it starts down here at y equals 0. Now notice I'm going to have a soft bracket at 0, goes to +infinity. Soft bracket at 0, that's because this will never get to y equals 0. So it's a soft bracket because 0 is not included. All right, you try. Graph and find the domain and the range for y equals 4x. Okay, so make a t-table. I'm just going to get you started here. Make your coordinate plane and make your t-table. Plug in x values and find your y values. I suggest just use these same ones: -1, -2, -1, 0, 1, and 2. Here, I'll just fill those in. So try those. Find your y values, plug them in, draw your graph, and find your domain and your range. Okay, go. All right, let's check out how you did. When I plug in -2, then I get 1 over 4 squared. So 1 over 4 squared is 1 over 16. I plug in -1, I get 1 over 4. I plug in 0, I get 1. I plug in 1, I get 4. When I plug in 2, I get 16. All right, those are my points. Now I just need to plug those in. I'm going to make some big delineations here again. Oh, I got to go all the way up to 4. Okay. -2, 1/16. -2, 1/16. That's very close to the x-axis. -1, 1/4. There we go, right there. 0, 1. 1, 4. And then 2/16 is way up here somewhere. So now I'm going to draw my line, or not my line, but my graph here, my exponential function. There it is. Got arrows on both sides. Now I need my domain and my range. My domain, this goes to infinity to the left and infinity to the right, so positive infinity, negative infinity to positive infinity. Goes forever on both directions. For my range, it starts at 0 again, but it never gets there, so it's a soft bracket at 0, goes up to positive infinity. All right, let's keep moving. Let's talk about transformations of this. Transformations. So here we have f of x equals a times b to the x minus h plus k. So this has all of the parts of an exponential function, and we're going to talk about what each one of these will do to transform or manipulate our parent graph. So let's start here. The plus k, this is the vertical shift. Vertical shift. So if this is positive, it moves the whole graph up. If it's negative, it moves the whole graph down k many spaces. Now I'm going to come over here to the left, to this a over here. If it's negative, if a is negative, it reflects on the x-axis. All right, now we're going to still be looking at this a. If the absolute value of a is greater than 1, it's stretched vertically. So it gets steeper. If the a value is greater than 0 and less than 1, as in it's a fraction between 0 and 1 or 0 and negative 1, this is compressed vertically. Meaning it gets flatter. Okay, now we're going to look at this x minus h thing here. This is the horizontal shift. And subtraction moves to the right h spaces. Addition moves to the left h spaces. Yeah, we're going to leave it at that. So let's graph something. Here's my example. I've got y equals 2 to the x power plus 1. So I'm going to take my coordinate plane, and we're just going to graph this without using a t-table. We know that y equals 2x is going to look something like this. And this should be like a dotted line, right? Because this is the parent. Y equals 2x is going to look like this. And it's going to go through here, this point, 0, 1. I know that because if I plug in 0, I'm ignoring the plus 1 here. I'm just graphing y equals 2x right now. If I plug in 0 for x, then I'm going to get 1 for y. So this is my parent graph. And then this says plus 1, so I just move it up 1. So right here, this is 0, 2, and then my graph is I'm going to draw that in just a second. I want to move my asymptote up as well. Right now I have an asymptote at y equals 0. Now I move that up 1 just like I moved this point up 1, just like this tells me to move everything up 1. So my asymptote moves up 1 as well. So I have my asymptote at y equals 1, and now it's easier for me to draw my new transformed graph. There it is. Now, in this case, my domain, I go all the way to the left, I go all the way to the right. It's negative infinity to positive infinity. And my, my range starts at 1, that's my y value, not included, and it goes up to positive infinity. Now, I also need to talk about my asymptote, and my asymptote is y equals 1. Let's do another example. Y equals negative 1/2 times 5 to the power of x minus 2. All right, lots of transformations going on in this one. We've got an a value here, and we've got an x minus h value here as well. So let's do this work here. So I'm going to graph my parent function first. So I'm just going to think y equals 5x is my parent function. And so that's the one I'm going to draw first. So this is 0, 1 is where it goes through the x-axis, and it would look something like this. And then I'm going to, I can do these in any order. So I can move it here with my horizontal shift, or I can do what A is telling me to do. So either one is fine. But let's go ahead and let's do this horizontal shift first. So x minus 2. So if it's subtraction, I move to the right h spaces. So 2 is my h, so I'm going to move to the right 2. 1, 2, and there's my new point. And I draw my parent graph. There we go. Now this negative, so I'm done with this. Now I'm going to go over here to the a value. It's negative, flips it over the x-axis. So instead of being here at 1, 1, because I moved it over, oh no, 2, 1, sorry, 2, 1. 2, 1, I moved it over 2 to the right, so it's 2, 1. Now I'm going to flip it over so it's down here at 2, negative 1. So there it is. Flipped over the x-axis. Now this half, so I've done the negative, I've done the minus 2. Now this half compresses vertically, it makes it flatter. So instead of going steeper like this, I'm going to go out farther like that, so it's flatter. So that is my last transformation. It's flatter, there it is. And that's it should look something like that. So I didn't plug in any points. This is not an exact representation. This is what, just an idea of what it should look like. So now let's talk about the domain and the range and the asymptote. So the domain here, it goes all the way to the left, it goes all the way to the right. Again, negative infinity to positive infinity. The range, this goes all the way, it looks like it's going to the right more, but it's really going to be going all the way down as well. So it goes negative infinity all the way up to 0. But it doesn't get to 0, it gets almost to 0. Right here, it gets closer and closer to 0, but never gets there, because it has an asymptote at y equals 0. All right, let's do another one. Let's do a u-try, shall we? Y equals 2 to the x plus 3 power minus 5. So go ahead and do this one. Just do kind of, it doesn't have to be perfect. You don't have to plug in X and Y. Just use the parent graph and move it around. Just use the transformations to graph it. All right, go. All right, let's see how you did. Okay, y equals 2x is the parent, so I'm going to put a point here at 0, 1. And I'm going to draw my parent graph. It's going to look something like that. And then I'm going to move it to the right 3 spaces. Left, I'm sorry. Plus 3, it's addition, so I move it to the left. 1, 2, 3 spaces. So there we go at -3, 1. Then I'm going to draw my manipulated graph again. And then I've got -5, so I'm going to move this whole thing down 5. 1, 2, 3, 4. So it's going to go from here, 1, 2, 3, 4. So there's my, 5, sorry, 5. So I'm going to move my asymptote before I draw this thing. So here's my asymptote right now at y equals 0. I'm going to move it down 5 spaces. So 1, 2, 3, 4, 5. There's my new horizontal asymptote at y equals -5. Now it's easier for me to draw my, my graph here, and it's going to go like this. Going to go through -3, -4, and go up. So I'm just going to write that -3, -4, and then it's going to go up like that. Boop. So this is not a perfect drawing of what this should look like, but it's pretty good. Okay, y equals -5. So domain range, asymptote. Oops, asymptote. So the domain, it goes all the way to the left, it goes all the way to the right, so I know it's -infinity to +infinity. And then my range starts at -5, but not quite, but it's almost to -5. So we put the soft bracket, goes up to infinity, and my asymptote is y equals -5. All right, let's keep moving. We got one more page to go. And that is exponential decay. And then we're going to talk a little bit about growth factor and decay factor. Exponential decay. So we've got this same function, the same parent graph, f of x equals b of x. When it's decay, we have the fraction that's between 0 and 1. So the b value is going to be between 0 and, not 0 and 0, 0 and 1. Which means it's a fraction there, between 0 and 1. Okay, so let's do one. Example, y equals 1/2 to the power of x. So 1/2 is between 0 and 1. And so we're going to see that the graph is going to look a little bit different than the graphs that we have been drawing so far. So let's just do a t-table here. We're going to use these same familiar points that we've been using. So this time, well, let's plug in the easy ones first. Okay, so let's plug in 0 for x. So any number to the 0 power to the power of 0 is 1. Any number to the power of 1 is itself. So there it is, 1/2. And then 1/2 squared is 1 squared over 2 squared. So that's 1/4. Okay, now let's look at these -1 and -2. So let's look at -1 first. So 1/2 to the -1 power, that says flip me. I'm unhappy the way I am, so now I'm going to be happy if you flip me. So there we go, 2. Now 1/2 to the -2 power is gonna, that also wants to be flipped. So we're going to give this -2 to both of these here. So I'm going to end up with 2 squared over 1 squared. So notice how they're now happy because I switched them across the fraction line. So 1 squared is 1, 2 squared is 4. So my answer here is 4. Now let's put these points on the graph. -2, 4. -2, +4. Boop. -1, 2, 0, 1, 1, 1/2, 2, 1/4. So notice now my graph is going the opposite direction. Well, I don't know if that's quite an accurate statement here. But instead of starting low and going high, now it's starting high and going low. Notice it will never get to y equals 0 here. It's just going to get closer and closer and closer there. So I have the domain and the range and the asymptote. So the domain, it goes all the way to the left, it goes all the way to the right, so it goes -infinity to +infinity. For the range, it gets in close as it can get to 0, but never gets there, so 0 with a soft bracket, and it goes all the way up to infinity. Now the asymptote is y equals 0. You try one. Y equals 1/3 to the x minus 1 power plus 2. All right, graph this guy, and let's see how you do. Do the domain and range and asymptote as well. Go ahead and go. Okay, let's see how you did. I'm going to start with my graph here like this. And so you could do a t-table if you want. For this one, I should have said before I told you to go get to work on it, I'm just going to draw it the way that we've been drawing those other ones where we just used a parent graph. So the parent graph goes through 0, 1, and it looks like this. Because it is decay, I know it's decay because this is a fraction between 0 and 1. And so x minus 1 says I move this whole thing to the right 1 spot. And then I move it up 2 spots. So I'm going to move my asymptote up 2 spots. So it goes up 1, 2. There's my new asymptote at y equals 2. And then my point then is 1 above that right there. But it's moved over 1, right? So it's right here actually. Okay. And so then I draw my new graph. It looks like something like this. Okay. And so it should look something like that. And let's do the domain and the range and the asymptote. Domain goes all the way to the left, goes all the way to the right, -infinity to +infinity. Range, it gets closer and closer and closer to 2, but never gets there, but it goes up to infinity. And then the asymptote is y equals 2. All right, got just a couple more things to look at here. We're going to look at growth factor. So here is a formula that we're looking at. A of t, equals A times 1 plus r to the t power. So this looks pretty similar to the formula that we've been working with, but we've got some different values that we're plugging in here. So A is the initial amount. R is the rate as a decimal. And T is the time. Okay, so let's do a problem here with using this. So here's your example. We're going to start with